Then we cannot transmit the analog signal, so we will convert it to digital form, so we will transmit.
Why we have to convert it into digital form?
Because sir, we can transmit any information in a bit form, not an analogous continuous form.
No, it can be transferred in analog form only.
That will require infinite memory. Because for each and every instant we have some information, but in digital we have information at some particular interval after some interval.
It is not related to that one. It is not related to communication or other things. But what your system will understand. It will understand digital. But if it has to understand digital, but real world signal is not digital data.
Yes,
right? So analog data. So that is why you are using A to D converter. Okay. So again, when you want to take it outside, you can visualize only analog data. You can't visualize digital data. So that is why DAC converter came. Okay. So what type of ADCs you know?
ADCs.
You might have studied.
R-power ladder. ADCs. R-power ladder.
Flash type.
Flash.
Success approximation type. And sigma delta type. Okay. These are few types of ADCs which will convert analog signal to digital data. Okay. So how success approximation works?
Successive approximation.
How success approximation ADC will work? First, it will take a data. Okay. So you see. Okay. So whatever value it is coming, here your analog signal will be applied. Okay. So what is this circuit? This is sample and hold.
Yes, sir.
Like this completely, if you see, it is a sample and hold circuit. Okay. So initially when your signal is connected to this one, so capacitor will charge. Okay. After, to what value it will charge? It will charge to the instant at which what analog value is present there.
Yes,
Okay.
Yes, sir.
For example, you are having a constant DC. So it will charge to this value.
Yes, sir.
And after charging to this value, it will be closing this side. Means I am changing my switch this side.
Yes, sir.
So now it is connected to one comparator.
Comparator.
Okay. So here your data will be changing. Reference value will be changing continuously. Okay. How it will check? How it will know the data? See, for example, your value is somewhere 2 volt. Okay. So generally, if you see maximum value you can give to the ADC is 0 to 3.3 volt. So if your voltage is 2 volts at the pin, so how it will know that it is at 2 volt? First, it is a 12-bit ADC. So maximum value is 2 to the power of 12. Okay, 4096. It will compare with that one. Okay, if it is high, it will give a pulse 0 or 1. Okay, so if it is low, it will give 0. Again, if it is high, means if the value is above that one. If it is low, means it is not above that value. So our value is below this one. Okay, it is below 3.3 volt. No, this 4096 corresponds to 3.3 volt. Okay, since we can give 3.3 volt maximum to this one, so and here 4096 is the maximum value. It corresponds to 3.3 volts. You are understanding this one, no? So now if a 2 volt signal is applied to the microcontroller pin, so what it will happen is that it is less than 3.3 volt, so here low signal will come. Okay, so when it is now it will divide 4096 by 2. What is the value? 2048. Now it will compare with this one. Okay, now after comparing, what will be the value? If you convert, if the value is greater than this one, then it will see okay, then it will make high. Okay, in this way it will go successively, like it will continuously iterate. See, initially it will check the value 4096. Okay, if 4096 corresponds to 3.3 volt. Okay, next if the value is low, like low, when it will come, if the value is less than that one, if the value is less than 3.3, then it will give low signal. Okay, means it will understand that signal value is lesser than that. So now you understood that signal value is lesser, so it will divide it by 2. It will divide it by 2, 4096 by 2, and it will compare with this value 2048. Okay, now it will check with this one. Okay, if it is high, then it will go high. Okay.
Why? Sir, why divided by 2, sir?
Huh?
Why divided by 2?
In this, it will check divided by 2 by 2 by 2. This algorithm is like that. They have designed success approximation like that.
Each and every bit 11 bit.
Each and every time it will divide by 2 by 2 by 2 by 2, and it will check. So okay, when once it is getting high,
Yes, sir.
okay, again it will divide it by 2 and it will check, or it will multiply by 2 and it will check. So in this way it will oscillate around, like it will come 0 1 0 1, and it will completely understand that okay, this is the digital form of the data.
At what point it will be high?
Huh?
Because we are
When
dividing
compared, when this voltage, when it is what can I, when the analog signal value is high,
Yes.
then this value.
But every time we are dividing by 2, no? So value will be reduced every loop, for every loop.
It will, if it is higher, if it is 1, then it will multiply. It will adjust the voltage, it will adjust the reference value. Okay, it will, once it, after checking, it will adjust the reference value, because it has to know exactly at what point it is.
Sir, reference is variable.
हाँ,
Reference is variable.
Like-
Harvest time में वो reference हमेशा change होता रहेगा.
yes,
Each
yes,
and every successive.
yes,
Like sir, our maximum value was 3.3 and we have given the input as 2 volts.
yes,
Then 4096 is corresponding to 3.3.
3.3.
So 2 is below that 3.3.
Hmm.
So we
So
will
it
divide by 2.
went 0 and it came to 2048,
So then
and
what
it will
is-
check here. Again it will go to other value.
What sir?
It
After
will
two-
check between these two values 4096 and 2048.
Now 2048 3.3.
Huh. No, now 2048 is not 3.3.
It's 2 also.
It is some other value. It is 3.3 by 2. How much? 1.65.
Yeah.
And these values are updated in the reference value.
Yes. These values will be continuously updated in the reference value.
So it will be less than 2 volt.
It is less than 2 volts, so that is why it is high.
Okay. Then it will be high for all the time, sir, because
No, again it will change the reference value. After again it will change the reference value.
But sir, if we divide 1024 will come. Then
1024
that will be also less than 2 volt.
No, it will adjust the reference value. I am saying no.
In next
So-
step it will multiply, na sir.
It will multiply. Again it will adjust the value.
Why multiply, sir?
Because
It is like 4096. It will take the value between 4096 and 2048.
ऐड हो जाएगा.
Now it will compare with this one.
So this is the bottom limit and this is the upper limit.
Yes.
But sir, what value it will take between those two?
No, this is not bottom limit.
Why you think?
Again, because it came to know that the value is between these two, no?
Mhm.
Now it has to go to the near to that value.
कैसे जाएगा?
सर एक साइकिल से रेफरेंस बताइए ना कि जब मेरे रेफरेंस वाली इनिशियल कंडीशन पे मेरे रेफरेंस वाली 4096 है
हाँ.
तो उसके रिस्पेक्ट में मेरा प्लस पे कौन सा वैल्यू आएगी 4096 का मेरा रेफरेंस वैल्यू है
हाँ.
तो उसके बेस पे मैं इनिशियल साइकिल से चल रहा हूँ
हाँ.
उसके बेस पे मेरा अभी 3.3 वोल्ट उसका इनपुट है कंपेयर कर रहा तो उसके बेस पे मेरा आउटपुट क्या आएगा फिर साइकिल के बेस में कंपेयर करूंगा तो
In this one, it will be 0.
So right now this condition the reference value is and the actual value मतलब वैल्यू क्या रहेगी सर उसकी कुछ टाइम पे
Reference value is 4096.
यस सर
And your actual value is at 2 only.
3.3.
3.3 वोल्ट ना
Your actual value is at 2 only.
2 वोल्ट
So now these two will get compared.
कंपेयर्ड होगा
So it understood that okay, this value is lesser than this one.
ओके तो नेगेटिव जीरो आ गया
हाँ.
तो उसके बाद अगली साइकिल में जाऊंगा मैं
हाँ.
वहाँ पे रेफरेंस की वैल्यू क्या आएगी सर वो डिवाइड हो
Again, it will
जाएगा
divide by 2.
डिवाइड हो जाएगा
Again, it understood that the value is between these two because 2048 corresponds to 1.65.
यस सर
Okay.
रेफरेंस बन गया मेरा
Now it understood that okay, my signal is between 4096 and 2048. Now it has to go to the near value.
Near value, हाँ.
So again, it will go to the value between these two.
ओके सर
Okay, it will take the average of these two and it will go to the value of by 2. It will do.
4096
It will add these two and it will do by 2 and it will check that value.
मतलब सर मेरा फर्स्ट साइकिल में जब हाई लेवल पे रहेगा 1
For some time it will be high.
हाई लेवल तो
Again,
रेफरेंस
it will change the reference value.
दैट टाइम माय रेफरेंस ओनली 2048
हाँ.
टाइम
हाँ.
2048
हाँ.
उसी टाइम पे मेरा प्लस की वैल्यू क्या रहेगी सर
2 volts only.
2 volts only
2 volt.
so that time my output is plus only
हाँ.
that time plus also
Yes.
the next cycle goes to zero value
हाँ.
then 2048 divided by 2 ones हो जाएगा फिर
No, next into
No, again, here it is changing the reference value. No, 4096 plus 2048 by 2 it is doing. No? Now it will compare with this value and it will check with respect to 2 volt.
Yes, sir.
तो हमेशा मेरा 2 वोल्ट फिक्स रहेगा
हाँ, 2 volt is your input signal. How you will change that signal?
बट सर जैसे हमने उन दोनों को ऐड करके डिवाइड किया दूसरे
You can, then give 3.3 volt as an input. It will check that okay, my value is 4096 and it is equal to that one. So it will give high.
4096.
Okay, first it will check, first it will make less than 0. Okay, and it will check where the value lies. Okay, if it is like it has to check it is exactly 3.3 or not also, right? So it will check it to 2048 and it will understand that okay, it is greater than 2048. Then it will make it high. Like that it will generate the digital value. This digital value will go into the ADC. Okay.
So like for example, if we have two values,
Until it converges, it will go continuously.
if we have so like 2 volt and 2.01 volt,
Yes.
so pulse will be same, no, sir, for some time.
2 volt and
2.01
2.01.
volt.
It will be almost same.
Then pulse
Here,
will be same.
pulses will be almost same. That is called as error. Okay. There will be some error in this one. It is not exact. Okay.
Sir, like if we are adding those like 4096 plus 2048 divided by 2, it is coming at 3072.
So now it will compare with this one. If you convert this 2 volt, how you will convert this 2 volt into digital data? 2 by 3.3 into 4096. Okay. Now if you do this one, it is converted into digital data. So it will convert this. It will compare with this this digital data with this one. Okay. This is for your understanding. I am saying in this way. Actually, it will compare everything in analog values only. Okay. Here there will be a DAC. So it will compare everything with corresponding analog values. Okay. And it will generate a 12-bit data. 0 1 0 1 0 1. Okay. You will get 0 1 0 1 1 1 0, something like that. Okay. 12-bit data you will get, and this data will go to your result registers. Okay, where it will store this result. Okay.
12-bit processor means it will go for 12 cycles.
No, 12 bits means it is 12 locations. Store 2, 3, 4, 5, 6, 7, 8. This is 8-bit, no? 8 locations for storing the value. What is 1 bit? 1 bit is 0 or 1. Okay, like that 12 bits will be there. So it will store 12-bit data in this. Okay.
Is it necessary that within 12 bit the value will get converged?
It will be in 12 bits only, because it is a 12-bit ADC, so it will be within 12 bits only.
And what if the value won't get converged?
It will converge, because your value will be between, it has to be between 0 to 3.3 only. You can't do higher than 3.3.
Sir, when it is low, how it will work? Like after 4096 plus 2048 by 2, the reference value corresponding to 2 volt, it is less. Then
Yes.
that time it will be giving 0 again.
It will be giving
So
0
then
again.
what will be the next step according to that?
Then again it will check that, okay, it is 0.
Yes, sir.
So now it will change the reference again, reference value.
In that case, what will be the
Now it understood that it is lesser than that value,
Yes, sir.
whatever lesser than this value.
Yes, sir.
Okay. Now it will do again with this value and 2048, and it will divide it by 2. It understood that now value is between this value and 2048. Now it will do between these two values. It will oscillate between these two values, and it will finally converge to that value. Okay. You understood, no?
Yes.
This is basic understand. This is basic about successive approximation. Okay. I explained this because when you go into this ADC, right? When you understand the controller ADC, mostly in any controller, you will see successive approximation type ADCs only. Okay. So that is why I explained this. Okay. This is only rough. This is not fair. Just I'm making you understand.
Actually, I get an idea about what actually comparator works. I mean, SAR type actually works. Actually get the idea. So that's why I've done this. How to generate actually pulses? Because I'm a little bit confused.
It is like
Little bit confused.
I'll explain you again afterwards. Okay.
Sir, in the next time it will add 3072 and 2094 divided by
2048.
2048 and
And it will check the average of these two,
yes.
and it will compare with that
Like
value.
value of the 2 was for 2 it was coming as 2482.
2482.
So after that it like when we taken the average it is coming 3072, which is more than that actual 2 volt value. So it will check the average again 3072 and 2048.
2048, and it will check the average of that one.
Okay.
and it will compare with that 2 4 some value is coming.
248.
It will compare with that value. If that value is higher, it understand that okay, its value is higher than this one. Now it will make that range. It will reduce that band, and it will come. Finally, it will converge.
Like if the bit is more, then data will be accurate.
Yes. Yes. Exactly. If the bits are more, data will be more accurate. That is called as resolution. Okay.
Address procedure, sir.
Next step is compare principal squared over.
Sir, that address procedure will continue for every further process. That address that we are doing, whether it will get continue for every further procedure.
Okay. I explained you like initially if you see here, this is a signal. Okay. This is the input channel. Channel means one analog value, like one analog input here you will be getting. Okay. These are 15 channels, means you can give 15 inputs at a time. Okay. One input is called as one channel. Okay. You have 15 channels, means you can give 15 inputs to the ADC simultaneously. Okay. So here you have mux. Mux will select the channel. Okay. And as I told you, sample and hold circuit is there. In this, simple capacitor will be there. Okay. And this capacitor will be charging this, will be charged to the input value, input channel value, and it will give to the ADC converter. Okay. So when it is given to the ADC converter will convert it into the digital data. Okay. And this digital data is kept in the result registers. You have to convert, after converting you have to keep the data in some storage place, right? That is called as register, and this is result register. You are keeping the results in that, so it is called as result register. Okay. So what is the use of SOC here? What is meant by SOC? SOC is start of conversion. For in SAR register, if you want to initiate a conversion, if you want to initiate an analog to digital conversion, this SOC signal is used. Like it is used as a trigger. Okay. If this SOC signal is high, then it will understand that okay, I have to do one conversion. So now how this SOC signal is generated? Because if you want to generate a conversion, you understood that you have to generate an SOC conversion. Means you have to generate a high signal for this one. So how you will generate this SOC? There are multiple ways of generating the SOC. Okay. Here if you see, you can see that SOC triggers. Okay. These events will trigger the SOC. These events means these are the things. You can discuss later. You discuss later. You will miss this again. You won't understand. You will get discontinuity. Okay. So if you see here, this SOC is very important for conversion of A to D. Okay. So how you will generate this SOC pulse? SOC pulse can be generated with these five values, like 5 triggers. Okay. So software trigger, CPU timers, you can generate with CPU timers, EPWM, software, external interrupt, and one more it is there, ADC interrupts. Okay. These are main for generating the SOC signal here. Okay. So you can generally we use EPWM signal for generating the SOC.
Okay.
Why? Because if we see in power electronics, PWM will control the current and voltage,
Yes.
right? Ultimately, why you are taking the feedback? For controlling the current and voltage. And if you see according to control, what must be the sampling frequency? It must be the double or equal, almost you have to sample at the PWM frequency. Generally control will say that you have to sample equal to the switching frequency or double the switching frequency. How you will know that switching frequency or double the switching frequency? From this EPWM. So that is why EPWM is made as a trigger. And CPU timers. What is the specialty of CPU timers? CPU timers, if you want to generate, what is a timer actually? You have any idea of timers? Previously you have encountered any time about timers? Timers is nothing but if you want to generate an interrupt, or if you want to generate any event with periodical time,
Yes.
okay, then you will use timers.
Clock cycle.
Okay, clock cycle. It is based on clock cycles. Okay, CPU timers means it is based on CPU. It is based on CPU clock. It will generate that event. Okay, this CPU timers will generate an SOC, and software will also generate an SOC. Okay, remaining external pin and software are not that much prominent, but generally we use CPU timers and EPWM for generating the SOC signals.
सर SOC का और एक बार बताइए कि इसका वर्किंग एक्चुअली क्या है? SOC क्यों मेन?
हाँ, SOC is mainly used for, I told you, right? It is mainly used for conversion. If you generate a high pulse, it will understand that okay, your ADC will understand that okay, I have to convert the analog signal to digital value.
And so when SOC is
Not there, it won't convert. It will be ideal.
मॉनिटर करता है तो SOC मॉनिटर करेगा तो
No, it will generate. It is a trigger to the ADC. It is a trigger to the ADC for making ADC to convert analog to digital data. Okay.
सर एसओसी का रिक्वायरमेंट क्या था? जब हमने सैंपल होल्ड वहाँ पे किया, फिर उसको रिजल्ट्स को हमें पब्लिश करना था डिजिटल फॉर्म में.
हाँ.
So what was the use of एसओसी?
If your ADC will convert analog to digital value, but ADC should know that I have to convert the digital value at this instant.
उसका मेमोरी है ना.
So we will
Like
provide the
it
trigger.
won't convert every time, right?
Yes.
It won't convert every time. Real value, whatever microcontroller will see, it will be discrete values. It won't be continuous values. It won't do continuously at like irregular intervals. It will be doing at periodical intervals. So at periodically you will be triggering a pulse, SOC pulse, so that it will trigger
At that instant. It will save the memory.
Like you won't get any noise or you won't get any unwanted values mainly, and you will get sampling equally. You will get at regular intervals.
Like we have given a 2 volt data.
Yes.
So how we can know that at what time we should convert?
Like what you will do, like like you have a constant 2 volt data. Okay, so you made a sampling frequency of some 100 Hz or 200 Hz. Okay, you want to reproduce the data same data onto the ADC output. How you will reproduce? What must be the sampling frequency? Actually, if you sample at particular rate, you can reproduce the same value at the output of the ADC result, ADC registers. Okay, at what rate you have to sample? You have to sample at double the sampling frequency.
Okay, 2 plates.
Like, okay, what is the frequency of this signal? You have to sample double the 2 times the frequency of this signal in order to generate the signal. You know Nyquist sampling theorem, no?
Yes.
Same Nyquist sampling theorem. If a 50 hertz signal is there, you have to sample at least 2 times for generating. Means at least it has to be 100 hertz to know that some positive data and negative data is coming.
Means sampling means SOC should be 100 hertz at that time. So for 50 hertz.
I am saying for 50 hertz. That is the minimum value.
Yes.
I am saying minimum value. You have to keep above the minimum value, far above the minimum value. If you want to reproduce a signal exactly, if you keep 100 hertz, you won't get exact value because it will take this data and this data. Remaining all data is gone. So if you want to produce exact data, you have to sample at each and every instant regularly.
Yes. But the, like if any DC data is there, 2 volt DC, there will be no frequency.
Then what is the frequency of DC?
Zero.
0. So you can decide the sampling frequency. Zero, no?
Then it will not convert at any time. No?
You can keep above 0.
One data will come.
Only one.
Like you can keep some value above 0
Okay.
so that it can reproduce the complete waveform. You understood, no? Continuously if you sample, what will happen?
Nothing. Same.
You will get the same data.
If we sample once, then it is exact.
Yes.
Because it is constant.
Because you have to understand that it is DC. So you will sample continuously, you will get the data value around that
Same.
same value. So you will understand that it is a DC value. Okay. Now this it will be keeping the data whatever it is converted in the result register. What is the use of EOC? What is the meaning of EOC? EOC means end of conversion. Okay. End of conversion means it has to understand that okay, I have converted from analog to digital value. Right. If you have given a trigger, start of conversion trigger, you should know that okay, controller like main CPU has to understand that okay, my data is converted. Then only I can access the data. It is not that okay, you have given the trigger and I will take the data randomly. It can't be like that. So you should understand that okay, my ADC has converted the data and it has kept in the register, then only I can take the data after completion of the event. So now this EOC will speak about the end of conversion, means your conversion has been done. Okay. Now it will generate an EOC, this EOC will generate an ADC interrupt to the CPU, main CPU. So that your main CPU will understand that okay, the conversion is happened. Now I can take the data as a feedback and I can control my system. Okay.
This EOC is also having some frequency.
EOC, whatever rate it is converting,
Same rate. It will
same rate, like it will generate the conversion. It will generate. Exactly I don't know, but this will be checking across this one. This will be checking. This ADC generation logic will check across this one.
So EOC result I mean mux picking.
This in order to select mux is just only for selecting the register, right? You can keep the value in any one of the registers. It is not that you will keep only in one register.
नहीं सर EOC तो AD converter पे ही जाना चाहिए ना end signal देने के लिए उसको.
No, ultimately you should know that your result is in result register, no?
तो सर फिर result से EOC आना चाहिए.
EOC is basically pulse, no? Trigger pulse.
हाँ,
So
trigger
whatever
pulse.
result is stored, we will trigger to end the to use that. We are using that result using the EOC only, no?
No. Actually, he is saying that if it is understanding that whatever result is converted from this one, it has to go from this one to this one. You are saying that. Like it is correct, but I will see once. Okay. I will tell you. As I discussed, you can see here, these are all these are triggers for the SOC, and you can select the channel. See, what is this selection of channel? ADC SOC control register is one register for selecting the channel, sample window. All this you can select through ADC SOC control register. Okay, and you can select the input trigger for the SOC also. Okay.
सर SOC and EOC मेरा हमेशा पल्स डिसाइड करेगा. जब SOC EOC नहीं रहेगा तो मेरा पल्स कितना कन्वर्ट हो रहा है वो पता नहीं चलेगा. लेकिन जब SOC and EOC रहेगा तो मेरा को स्टार्ट और एंड का जितना विड्थ मुझे पल्स मिल रहा है वो डेटा वो मुझे आउटपुट में भेजा.
No, it is not like that. SOC will see when SOC is generated, so it will give a trigger. So this value will be converted by ADC.
Yes, sir.
For example, some value it will convert. Okay.
Yes, sir.
This it will be 12 bit. Okay. Some 12 bit value is there, and at the end of this value you will get EOC.
And what will EOC do in this?
In this, EOC will give a trigger to the interrupt or CPU.
Twist over the
Like to access the value. Okay. Now, what is the ADC conversion? Like priority ADC.
जो हमने pulse बनाया 2 volt के लिए,
हाँ.
that pulse, so who will decide that width of the pulse? Like it is on, so how much time it should on, and it should check the next average value to compare.
It will. That is based on SOC, no?
Sir, suppose कि
Like till the next conversion is done.
If the trigger for the next
No, sorry. It will do continuously, inherent. It will do 12 bit data conversion at a time. Low, see, high, low. How much it is, how it matters. You are getting finally the digital value. You can see only the digital value. How much pulse width, all this, it doesn't matter.
Okay, 1 0 1 0.
You will get only 1 0 1 0 1 0.
RAM और ये सब में मेगाहर्ट्ज नहीं दिखाता है, वो फ्रीक्वेंसी उसकी की होती है कि कितना फास्ट सिग्नल दे रहा है.
Okay, so ADC conversion priority means if you want to generate an SOC, there are number of sources for generating the SOC. Like we can generate number of start of conversions. Okay, so how many start of conversions you can generate? From 0 to 15 you can generate. Okay, SOC 0 to SOC 15 you can generate. Means 16 start of conversions you can generate. Because you have 16 channels, you can generate 16 start of conversions. Okay, and now how you will decide the priority for each start of conversion? Because why we have to decide the priority? Because our start of conversion, 2 signals can come at a time. For example, start of conversion 1 is coming and start of conversion 7 is coming at a time for as an input. It has to take one as a priority and it should leave other, and it has to convert the data. You are understanding, no? So if 2 start of conversions are coming at a time, so how it will understand that I have to give a particular priority to that one start of conversion. So here round robin counter will decide the priority. Okay. In round robin, what it will decide is that first initially you can think that it is at 0. Okay. and you have initiated a start of conversion of SOC1 and you have generated a start of conversion of SOC7. Two start of conversions came. SOC1 and SOC7 came to your signal, okay, for conversion. Now your pointer is at 0. Now it will decide that okay, it will go through clockwise direction. It will rotate clockwise direction and it will check which is coming first. It will come, SOC1 is coming first. So it will convert the SOC1, it will give priority for SOC1 and next it will go to SOC7. Okay?
It will check every SOC.
No, it won't check, it will check every SOC and then first it will go to SOC1, then next it will go to SOC7. Okay?
Like sir, for a one case, two are coming like SOC1, SOC7, it will go for SOC1. Then for another instant, it may come for like 3 or 4 or any other.
If for example SOC1, SOC4, SOC7 is coming,
Yes.
then one it will take, then SOC4, then it will go to SOC7.
Ascending order.
It will check ascending order.
Ascending order.
Sir, suppose at an instant 1 and 7 comes and in the process of doing 1, again 4 comes.
In the process of doing, it is like an interrupt.
Yes, sir.
Then that is different situation. Then it will keep after some time. After doing 1, it will do 4 then.
Not 7.
Huh?
Not 7.
Because your priority is going in this way, no? Your priority is going in this way. At that instant, it is at SOC1. It didn't cross SOC4. If it has crossed SOC4, then it will go. Priority will go to 7. Okay.
When it is switching the SOC, it will check the EOC pulse also.
No, that is different. EOC pulse will be checked only after converting the digital data. EOC pulse will be checked only after converting the digital data, not at the start of conversion. Okay.
And sir, how it will be coming? What will be deciding that which trigger SOC 12 or 2 is coming simultaneously?
You will be deciding.
You will decide.
You will be deciding because priority is in your hand. You know that okay, I have to make, this is my priority. SOC 0, SOC 1, this is my priority. Now you give your own priority to your signal. Okay.
Then we choose the near one.
Which you want to give high priority, you give SOC 0. Which you want to give SOC 1, you give high priority to that signal. Okay. Now what is high priority? High priority is nothing but now you want to give, just now we are discussing that I want to give more preference for SOC 0 to SOC 3. Okay. For this range I want to give more preference compared to other SOC 4 to SOC 15. So I will make this as high priority registers, SOCs. Okay. I will configure this SOCs as high priority SOC and I will convert remaining to round robin counter. Okay. So now whenever this SOC comes, first it will convert this and then it will go to this. Then it will follow the ascending order.
First it will go for these 4.
First it will go to this one, first it will go to this 4, then it will go to this one.
Okay.
You understood, no?
So what if SOC, we have set SOC 0 to 3 as high priority and 0 and 2 come at the same time? Then we will do the same RR count.
Then again in this, it will happen the same thing. Again ascending order might be, I don't know, but I'm thinking because again in high priority also ascending order might be there. So again it will check SOC 0, SOC 1, SOC 2, SOC 3.
So how will you make these priorities in the system?
You will make priority. That is what I'm saying. You can make priority.
We do coding or?
In coding. These things are a bit deep, which you can't see in MATLAB. You will see only channel selection. What is your trigger? You can see only these things. You can see only channels. What is your trigger? what is your channel, and what must be your acquisition window, sampling window time. That's all. If you give these values to the MATLAB, then it will work. It will start working. Okay. So I think you might have understood completely, because I have discussed along with priorities also. And in this, one more thing, if you want, I think sequential and simultaneous sampling is not required. So you can go through. If you face any problem in configuring the ADC block, you can. Should I explain by taking one example?
Yes. Example.
Okay, I'll explain that. We have seen that ADC module has 4 ADCs. Okay, if you have seen first slide, you might have seen 4 ADCs, right? ADC A, B, C and D. Okay, so first in this one, first one, you can see which ADC module you want to choose. Okay, that will specify. Okay. See, here 4 ADCs are there, so you can choose any one of them. ADC A, B, C, D. Okay. And in this is single-ended input or differential input. What is single-ended input and what is differential input? Single-ended input means if you are taking your analog signal with respect to ground. Okay, if you are giving your ADC signal, input signal with respect to ground, that is single-ended input. Okay, if it is with respect to some voltage, like if your voltage can be your reference voltage, if you are deciding, okay, then that is differential input. Okay.
What is differential for again?
Differential input means if you are deciding your reference value, generally single-ended input means ground will be the reference value.
Yes.
Okay, differential means it is between 2 points, no? Between 2 volt, between 2 nodes. Here SOC acquisition window. What is SOC acquisition window? What is acquisition window? Acquisition window means if you don't pay attention, you can't understand anything. I will say only once.
Sir, can you please repeat from the right start?
Starting. See, here ADC module is there. Here in this ADC module you have 4 options, right? A, B, C, D. You can choose any one of them.
Sir, which ADC?
Huh? Here you have 4 options. You can choose any one of them.
So means in MATLAB we can use 4 ADC as an
Like in this launchpad you have 4 ADCs. Okay. So A, B, C, D. Those are A, B, C, D.
Yes, sir.
In 28379D you have 4 ADCs.
Yes, sir.
So that is why 4 ADCs are coming here.
Okay. Yes, sir.
Okay. So you can choose any one of them. And single-ended input means you are giving an input signal with respect to ground. Okay. You know differential input means anyhow you know, because you know differential op-amp. Like with respect to 2 nodes you are giving an input to the ADC. Okay. SOC acquisition window. What is acquisition window? What it will decide? Acquisition window is nothing but, as I told you, in sample and hold circuit, capacitor will charge. Capacitor won't charge immediately, right? If you are giving an input signal, it won't charge immediately. It will take some clock cycles to charge. Here it is, I have decided that 15 clock cycles is my input. that time I am giving so that it will adequately charge. Okay. I am repeating this one. Acquisition window will decide the capacitor charging time. Okay. Capacitor won't charge immediately, right? So it will take some time to charge. So that is why I am giving 15 clock cycles. Here 15 means 15 clock cycles. Okay. And here what is the source of trigger for my SOC? Here I have given CPU timers. If you click on this option, you will get different options, right? Here what options you are getting? Software, CPU timers, external interrupt, EPWM. Okay. You can give any one of them. Okay. Now for now I am discussing about CPU timers only. If you want to explore EPWM SOC, you can explore. It is available in YouTube. You can see and you can understand. Okay. If you have any doubt, you can ask me. For now I am explaining only with CPU timers. So I have decided I will take with CPU timers 0. So I am taking the SOC trigger as CPU timers 0. Okay. And I don't want to generate any interrupt for any interrupt, ADC interrupt as a SOC trigger. So I am making no ADC interrupt as SOC trigger.
Single channel is
Means your source, I told you initially that ADC interrupt can also be your SOC trigger. Okay. So now I don't want to keep ADC interrupt as SOC trigger. So I kept no ADC SOC interrupt. And what is your sampling time? Here in MATLAB maximum sampling time is 1e minus 4 means 10 kilohertz only. You can't go beyond 10 kilohertz. That is major disadvantage with MATLAB. If you do coding, then you can go to your sampling, your own sampling frequency. Okay. And data type. What is this data type? Here unsigned integer 16. Okay. Means it is not having any signed value and it is an integer value of 16 bit. Okay. Because your ADC data is 12-bit data, so and it is not having any negative values in front, so you are using unsigned value, and your ADC data is 12-bit only, so I am using 16-bit data. Okay, and integer value. It is not float value. In your ADC, you won't get 4096.001. You won't get like that. You will get 2048, 2047, 2046. So those are integer values only. So that is why I am choosing unsigned int 16.
So 12-bit data from 12-bit is left.
But it will accommodate in 16. You can accommodate in 16 bits, no? So that is why I am accommodating in 16 bit. Okay. After conversion, what you want to do? And with the end of conversion, you want to trigger an ADC interrupt.
Yes,
so I am triggering ADC interrupt 1. Okay. So after converting my digital data, I am triggering ADC interrupt 1. Okay. And I am doing this ADC interrupt continuous mode. I am keeping it in continuous mode. Okay. After this, here you can see the channel selection. What is ADC in 3? Launch. I want one launch.
Yes, sir.
Here, if you see ADC, which channel you want? See. See, ADCA has from 0 to 5 inputs, okay, and B 0 to 5 C same 0 to 5, and D also has from 0 to 5. Okay, you might get the doubt that okay, here 20 channels are there, but why we have only 16 channels? But you can decide, this launch TI people has decided that we will give only 16 inputs onto the for the user, like for the user. So that is why you are getting only 16 inputs. Okay, remaining 4 inputs they didn't give onto the pins. Okay. Apart from this, you will have A14 and A15 also.
So which code will not be used?
I have to say.
You can't use it. Because on board they have not anyway given. Why? Because like we don't require 16 because generally 16 channel. So 16 is maximum sufficient.
Okay. So if you see on your ADC launch pad, if you turn back, okay, if you see, as I told you previously, A decides. If you see on back side, it will be starting with A. Okay, means it is an analog input. Okay, and ADC A, this will decide it is ADC A, and if it is written 1 means here it is channel 1 in 1. Okay, if it is AB2, now you tell me what it is. It is analog input, it is ADC B, and what is the input channel? Input channel here instead of 3 it will be ADC in 2. Okay, like this you might have, if you go back like onto the launch pad you can understand. It is related to channel A. For ADC A, it is not channel A, ADC A. Yes.
If it is AB2 we want to select in the launch pad, then here sir we will select AB, is ADC in 5?
No, here first you have to select this one. First here you have to select in module you have to select B, and then you have to select there 2. In channel, input channel you have to select 2.
Then what is the need of giving these 16 here? It should give only 5 because we have already selected the channel here. We have already selected A, B, C, D, either of them from here.
But if you are developing your own controller, okay, they don't know that MATLAB don't know that you will use this particular one only, right? These are predefined blocks. Like it can be used for same block can be used for other controllers also. You have to keep that also in mind because it is not only for 28379D. It is for 28004X. For remaining controllers also it is same block. That if you are keeping ADC C, here I am using ADC C3, right? So it doesn't mean that I have to use only SOC 3. Okay, you can use SOC 0 to 15 any value.
What is SOC? What that is kind of interrupt.
Trigger of the ADC.
So that means you can use any interrupt to see any of the things. Like once you say and look at it, will look all the things available there. Then it will take it.
Okay. This is about ADC configuration. Nothing much in this. So you can first check. I will give you an experiment, basic experiment. First on your launch pad you have 3.3 volt, right?
Yes, sir.
So you give this 3.3 volt to any one of the ADC pin and use MATLAB display block to check what value it will display.
Yes, sir.
So that you will understand what value it is displaying. Okay?
Yes, sir.
You will get a bit idea of, if you use DC first, then you will get idea. Then you can use sine signal. Next you can sample sine signal. Okay? First you do this and let me know. I will give you experiment on sine signal. This is basic experiment.
Yes, sir. Yes, sir.